Thanks everyone, good morning. So I'm David Mytton, I'm the founder of Server Density. I've been programming for almost 15 years now. I'm originally in PHP, but most of the time now in Python. And I created Server Density to help customers manage their infrastructure when it comes to monitoring and performance. So we look at your infrastructure from locations all around the world, tell you uptime and response times, and then get into the servers and help you manage, troubleshoot, and wake you up when things go wrong. So I built the original version of Server Density, and I also did the original deployment of Puppet, coming up to maybe 4 or 5 years ago now. But we didn't start with Puppet. I started just doing things manually. I didn't have time, or so I thought, and didn't think it was worth using a config management tool. But after 2 years or so, we switched over to using Puppet. And so I want to talk about why you should do it from the very beginning and not do what I did and start with nothing, but to actually get config management and specifically Puppet up and running. But before we get into that, on Reddit a couple of weeks ago, we started a thread around sysadmin jokes and have compiled them into a book. So if you'd like a free notebook with a compilation of the top sysadmin jokes, then just go to serverdensity.com/knock-knock and you can put your address in and get a free copy. So the focus of this talk is going to be around a few key areas. The first, just getting into the basics of why you should use Puppet. Then we'll look at some objections that you might have yourself or you might have heard from other people and how you can combat those. We'll take a brief look at how Puppet works specifically in cloud environments and why it's worth using it there. And then talk about a few unusual use cases which kind of demonstrate the power of Puppet. So the first question is, why Puppet? But before we start talking about that, actually, we need to come back a little bit and think about why config management in general. So when you're thinking about this, it's good to think about a similar question around why you should use source control. Back in the old days, there was no such thing as source control, and then we had the early versions, and now into Git and Mercurial, and thinking when you're on your own, why bother with source control? Or in your team, maybe you could just do something like Dropbox. But the same kind of arguments apply to why you should use config management, and so there's a nice analogy or comparison you can draw between the two. Well, the first of these, and probably the most interesting to developers, is the fact that it means your entire infrastructure can become code. Instead of obscure command lines or working with APIs you're unfamiliar with or control panels, you can use a standardized language across any environment, across all environments. It means you can define things within code that you're used to. Linked to why source control, you can put all of that code into version control itself. And so not only do you have your entire infrastructure described within code, but it also means that you can version that and you can go back through history, you can see what has happened over time. You can link that to problems which might come up in the future. You can link it to a specific change that you might have made in your infrastructure. You can use that classic git blame to figure out who made a mistake. You can then do a root cause analysis on that rather than blame the person, blame the process, and figure out what went wrong. And you can do reverts and use things like branches to make changes in test environments and use pull requests or similar to do code reviews. You can essentially bring your entire development flow into your infrastructure. And then on to the infrastructure itself. It allows you to get that consistency across all of your machines, whatever environment they're on. And this is important once you start going from a single server to 2, 4, 6, and so on. As your infrastructure expands, as everyone usually hopes it will do, you can get consistency across a huge number of machines. And equally, as you're scaling your machines, you're probably going to be scaling your team. And so bringing people in to understand your infrastructure, it's a lot easier to do if you can go through a single repository of all your infrastructure code versus having to log into servers, try and describe them using a package management tool, figure out where config files are, particularly if it's across different distributions. The Linux file system is always fun to try and understand where things should go on different distributions. And this is stuff that you just don't need to do if you're using a config management tool. And if you're in a large company, or if your company grows significantly, then you're going to come up across auditability. And that's figuring out what happened and when, whether that's for compliance reasons, if you're in a regulated industry like finance or healthcare, or perhaps more likely if you're coming up against security issues, whether that's investigating a breach or making sure that your security policies are applied across your entire infrastructure. That ties in with consistency, to make sure everything is the same, but then being able to verify that and prove it with the data. So there are a couple of use cases specific to config management which are worth calling out. These are things that you can do manually and you will do manually, but are made a lot easier when you're using config management. So package deployment, this is a fairly obvious one. Logging into server, running apt-get to install a particular package or installing the RPM. Doing this manually on a single server is okay, but if you've got 1,000 servers and you want to install the same package across all of them, then it's a massive pain. Using something like config management allows you to define it centrally and then let the config management tool roll it out for you, dealing with the operating system, whatever version it might be, all the intricacies of that, resolving dependencies, which you used to have to do a lot more in the olden days of package managers than you do nowadays. But this can all be automated, and it means you don't have to go into every single server and waste your time doing that. And then once you've got those packages installed, you might want to ensure that you're running particular versions. And I remember several years ago on Christmas Eve, I was at my grandparents' farm with Edge on my phone in GPRS, and it turned out that that evening tied in with a cron job which ran on the server, which automatically updated all the packages and upgraded our database, which wasn't so much fun to deploy and to try and debug, because the upgrade had changed something and we needed to go in and deal with an incident on very poor connectivity. But this can be solved by pinning your packages, not doing automated upgrades, setting a particular version that you want to be deployed. And this helps in a couple of different situations. The first being avoiding those automatic upgrades, so you can do them after a period of testing, and not on Christmas Eve, but when your team is available to deal with any problems. But it also allows you to have that consistent environment. So when you're spinning up new servers, the default is to install the latest package or something when you just run an install command. But that means that older versions that are already installed will become mismatched. And so you want to make sure you're always installing the same version across all of your servers and do a controlled upgrade when you're ready to do that. And so you can, of course, do this manually by pinning the server, pinning the package on the server itself. But it's a lot nicer to do it within the code, to pin a specific version, and then when you're ready, you commit the new version, you can see the change history, and that then rolls out across your server environment. So another one is config files, and these are always a massive pain to manage. You probably have them in source control already, hopefully, but they are going to be at different locations across different servers, different packages. Having them in a single location that's managed using config management means not only can you control the config file from a single canonical location, but you can also define templates and have the config written to each server based on specific variables. And this is useful if you have different clusters with different use cases. You might want to put database files onto different drives with different mount points, and having a huge number of different config files, trying to define those is quite messy. So instead you can use templates to help you with that. And then as your production environment matures and gets older, gets used, you're going to come up with bug fixes, tweaks, or patches that you need to make to your servers, to database applications, to your own code. And making these changes on an ad hoc individual basis is not generally a good idea, because you might miss a particular server, you might forget that you made that change, and then when you're launching new servers or trying to debug a particular problem, you don't know what's actually been changed. And this is particularly useful for performance tuning. As your number of connections increases or throughput increases, you may want to make changes to Linux kernel settings or database settings, and having those changes set in a specific location makes it a lot easier to manage those. You'll also find that particular patches might need to be deployed to particular servers. For example, changing the kernel version to fit to a particular CPU that is deployed or a networking card that is deployed. And instead of having to do these manually, you can obviously use config management, and you can have them applied based on particular facts of the server. So instead of having to know what CPU each server is using, you can just use the Puppet facts to get that deployed, that patch deployed on the servers that match that. So now we've given you a few reasons why you should be using config management. We can look at Puppet specifically and how the features of Puppet will help you with this. So the first of these is PuppetDB, and this is essentially your infrastructure as a database, and you can query it like a database. It allows you to do any kind of actions you might normally associate with database, reading data out, putting data in, understanding what's going on within your infrastructure. The next thing is Hira. This is a key value store and is ideal for config management. Previously, you had to use variables, and the now best practice is using Hira as a key value store. It makes it incredibly easy to deploy config changes around your entire infrastructure and manage them without having to make changes within a control panel or something like that. It means you can look up those values from within your Puppet code and make decisions and changes based on the settings of those. Well, Factor allows you to essentially do analytics across your entire infrastructure. And analytics is kind of a cool, shiny buzzword at the moment. And it means you can build things, you can figure out what's going on your infrastructure. It has particularly interesting use cases when it comes to security. So being able to find particular servers that match certain facts, that have certain packages installed, have certain things running, and allows you to get a list of all your infrastructure so you can make changes to them. So imagine, for example, trying to find servers that are running a particular version of OpenSSL and needing to patch those very, very quickly. You can use these tools, Factor in particular, to query your infrastructure and find those things rather than having to do it manually. And the Puppet Forge is an incredibly powerful resource to essentially have most of your infrastructure open sourced. You're not going to be an expert in every single thing that is running on your infrastructure. There are going to be other people who have spent more time, got more resources, have seen varying use cases for particular applications. And in many cases, or in most cases, those applications already have modules available on the Forge, with all the options that you might need already defined with templates and following best practice deployment guidelines. And this means it becomes significantly easier for you to deploy applications, whether it's a new database that you might not be familiar with and you want to figure out how to tune it, it's a web server module that you're looking for. Often there's going to be a module with experts who have already written it, either by the commercial company that might be behind the application or with the open source community. And this makes it significantly easier for you to deploy and manage the infrastructure. You no longer have to get into unusual performance tuning, research online, and you don't have to try and understand necessarily the full details of everything. It's already defined for you, and you've got a great starting place so you can deploy and learn with an infrastructure around you. And then if you're on the Puppet Enterprise package and you're willing to pay for that, then the advantage is one of these is having a graphical interface. So you can run reports across your infrastructure in a lot easier way. And it also allows you to do certain tasks easier. You might be able to give access to your team to do specific things, which can free up your time as a sysadmin or operations guy or girl trying to run queries against your infrastructure, to run reporting, and to maybe even make small config changes. You can give specific access to specific people to do those so you can free up your time for other things. Okay, so let's move on to some objections that are often heard and how we can address these. So the first thing that comes up, and probably the first thing that I considered when we're doing our infrastructure, is to only have a couple of servers, and so why would you want to use something as big as config management, whatever tool that might be? Well, the question to respond to that is, well, are you planning to grow? You might have one server today. Is that just a personal server? Or actually, are you working at a company, and is this going to grow? Is it a big application? Because if it is going to grow, then your time spent managing each individual server is going to increase if you do things manually. And using something like config management like Puppet will allow you to define these things up front and easily, much more easily, scale them across multiple machines for the reasons we've talked about. Do you want to have that consistent environment? So when you are growing your servers, then do you want them all to be the same and to have to avoid time wasting and troubleshooting when you're trying to figure out what is different from one server versus another? And even if you've just got two servers, then having them both the same is a great benefit. And even if you've got a single server, you can still have consistency between your production environment and your development environment. So one of the things we do at Server Density is use Vagrant to deploy code locally for all of our developers, and Vagrant is actually deployed using our production Puppet manifests. So it means that as much as possible, as much as you can, the Vagrant development environment is exactly the same or almost the same as the production environment. And so it's not just consistency across your production, it's consistency across production and staging, and then production and development, because everyone's always has experienced that issue where it works in testing but doesn't work in production. And one of the topics we'll touch about when we're talking about cloud, but is also relevant here, but particularly when you're using virtualized instances, what happens if you need to destroy the instance and recreate it? Whether that's a single server that you're just spinning up and testing things on, or if you're in an auto-scaling environment, destroying an instance and recreating it is just a standard operation in most cloud environments. It's done all the time. If you have to redeploy your code and your packages manually every single time, that's going to become really irritating. So the next objection then is the fact that it's too complicated and it's a lot easier just to do things manually on the server. So this is one of those things that the initial investment really pays off. It is time up front, but it saves time later. It saves time for all the reasons we've just talked about. Deploying across multiple servers, making sure you've got consistency, dealing with security issues, rolling out changes to packages, upgrades, all those kind of things. There is initial work up front, particularly if you have to build your own modules, but more likely than not, the modules will be available on the Puppet Forge. You can save time later. And so this is a worthwhile investment. And this kind of argument is similar to saying, well, it's too complicated to use a programming library. I don't want to have to learn all of the APIs around it. I'll just write my own. And this isn't really a compelling argument when there's a range of very good tools available to do this for you and to do all of the heavy lifting. And then the next objection is, well, I can just SSH manually to the server and run the commands myself. Well, you can do that. It's really easy to make mistakes when you do that. On a single server, perhaps less likely, but if you're trying to run the same command or do the same thing across a huge number of servers, particularly if you're not using config management, there might be some idiosyncrasies and differences between them, then you're probably going to make a mistake. And often this mistake is going to happen when you're responding to an incident at 4 a.m., when you're not in the best condition anyway to be dealing with things. It's much nicer for you just being able to make a change to config and then have that deployed automatically across all your servers by Puppet than to SSH in and have to figure out what commands you should be running on each server, what are the differences between it, and which servers you should actually be running this on. Remember, you can use things like Factor to figure out exactly what commands should be run and where. And if you're connecting to all of your servers manually all the time, then security becomes an issue. Whether that's your personal operational security, where are your SSH keys, how are they being deployed, what's the security of your personal system, what's the security of your network. whether it's the security of your team. Do all of your team have the same excellent security policies that you do personally? Are they as careful with their keys and how they connect to servers, where they're doing that over public networks or not? And then the security of just having lots of users who have access to all of your servers. You may have people within your organization that you might not trust as much as others, people who have to leave for certain reasons that you then don't trust them with the infrastructure. There's a lot of room for error and in particularly security issues when you're having to do things manually on servers. Again, if you're using config management, if you're using Puppet, you've got those audit logs. You can put in place policies around code reviews, and you can version everything and revert changes. And that auditability is much more difficult if you're having lots of people logging into servers. Either you don't have any logs about what people have been doing, or you've got them in some system where you've got to then pull out the logs, process them, figure out who was doing what, who was connecting when, and whether someone is connecting unusually, or if there's unusual activity on your network. If you don't have to think about any of this, then you can close quite a few security holes, or potential security holes. And then finally, the last objection is, well, I can just write a few shell scripts to do this. So this doesn't work at scale. Whether that's scale with large numbers of servers, and you've got to figure out how to get your scripts to be deployed across them, and then versioned across all of them, or whether you're deploying across multiple environments. In Server Density, we run bare metal on software, we run instances on AWS, we run instances on Rackspace Cloud, and we've got over 150 servers in 30 different countries around the world. And they're all running as much as possible the same, but there's differences with hardware, there's differences with operating systems. And even though we standardize on Ubuntu Linux, it may be that you have to run specific OS versions for particular use cases, especially if you're running Linux and Windows or different operating systems. Your scripts will have to be adapted to make sure that they work across all these different environments. They'll have to be kept up to date with changes to system APIs. And it really sounds like a lot of work when you can just use Puppet and let them deal with that with their 360 people, figuring out how to do all this for you. You can just interface directly with Puppet rather than having to figure out every single OS or vendor API. Idempotency is also important. That's being able to run the same script again and again and again and always get the same result and not mess things up. It's not impossible to build this, obviously, because Puppet have built it, but the whole point of using something like Puppet is you define it, and Puppet makes sure that it exists in that state. And no matter how many times you run it, it's not going to try and install the database 100 times. It's going to just do it once and make sure it matches your config. And so this is an engineering problem that if you write your own scripts, you'll have to deal with. It's not just a simple case of wrapping shell commands into a nice script. You've got to make sure that when you run them again and again, they're not just executing the same thing again and again. And then version control. If you're going to put your scripts into version control, then why not just write them in Puppet languages in the first place? So another side point now with the cloud and why Puppet makes sense in particular in the cloud. Most people are now deploying their so-called cloud first, if you want. There are a number of reasons why using config management, using Puppet makes sense in a cloud environment. So the general principle for cloud environments is that you have to assume failure. Now, a lot of people still don't do this, and that's why you see people going down when different regions go down, but being able to redeploy your instances, redeploy your applications when there is a failure, whether it's in a single region, a single availability zone, or maybe all the regions suddenly go down, you want to be able to redeploy and recover your environment as quickly as possible. So if you're not using config management, you've got to do all this manually. You've got to log into servers, and you've got to figure out what went wrong, and what the state of all your environment is, and this can be a massive pain to do. If you're using Puppet, then it can do everything for you. You may not even need to log in or even be woken up. If something fails or an instance disappears, using the cloud provisioning modules and functionality that Puppet has, it will just automatically start things up, install packages, and bring everything back up to speed. One of the great advantages of the cloud is the ability to scale really, really quickly. It's that so-called unlimited scalability that you don't have if you have an on-premise environment. And so the principles that we talked about around consistency really make sense here. If you've got thousands of instances, then you want to make sure they're all the same, because if you're debugging performance problems with a particular instance, it's a lot easier just to destroy it and recreate it and know that everything is the same. You can rule out a lot of problems and save a lot of time up front when you know that your whole infrastructure is exactly the same. And managing large clusters, everyone wants to have a large number of servers to deal with. It sounds really cool, but if you have to manage them manually, then it's a real pain. And using Puppet tools makes things significantly easier, and you can get rid of all that undifferentiated, heavy lifting stuff that you really don't want to be doing, and focus on the really interesting problems that you come up across when you're scaling things. And because you have these huge numbers of instances, you're going to want to know what the state of your environment is, particularly across cloud providers. And we're seeing more and more that people are deploying hybrid environments. Currently that's kind of hybrid cloud and on-premise, but into the future it's more going to be hybrid cloud across multiple cloud providers. And being able to query the different states of your machines from a single location is a really powerful tool. You don't have to go to a specific vendor's system. You can do it from an abstraction, which is the Puppet factor. Now finally, I'm going to talk through a couple of use cases at server density. We've talked about config management. I think hopefully explained why it makes sense to do that, and Puppet is the original reason for Puppet is to do that. But there are a couple of interesting use cases that the likes of Hiera, PuppetDB, and Factor allow you to do. The first of these is deploys. At server density, we use Puppet to deploy our applications, deploy our code into staging and then into production. And this starts off using BuildBot. We run all our tests. We convert the development versions, running things like build out to get the right packages within the Python environment or whatever it is we're deploying. Create the build artifacts and have them ready to deploy. And we then have a list of all of our servers and all of the key services that make up server density and what the version is that's deployed. And we build this by using Puppet, by querying Puppet to figure out what is deployed on each individual server. And this gives us a good view of whether a particular version is deployed, what the GitHub commit is on it, and we're querying our infrastructure. It allows us to do it from a central location. And we can then deploy particular versions from GitHub, from our builds, onto particular servers. And we've built a simple interface around this. It ties into mCollective, ties into the PuppetDB, Puppet Interfactor. And when we click a deploy, it makes a change on the server, which the Puppet agent notices, and then makes sure it's deploying the correct version that we're telling it to. And this is a really powerful way of us building our own deployment system without having to do much work other than build the interface on top of it. Now there's several different SaaS providers that allow you to do this if you don't want to build your own thing, but it's not difficult to do it. With all the tools and the APIs that Puppet provides, it's quite easy to query your servers, tell them you want a particular version of your code deployed, and then let Puppet do it. Let the Puppet agent copy all the files, let it restart services, let it update config files, and let it do it in an idempotent and consistent manner across all of your servers. There's another use case, and that is documentation. And this is something that everyone hates to do, really. You don't want to be documenting stuff. And most of the stuff you don't have to document anymore because it's already documented because it's in code. Obviously, there are some things that you can't just describe in code, like failover procedures, checklists, those kind of things. But using something like Puppet, having all your infrastructure defined in source control means that it's essentially already documented. You know what packages are installed. You know what versions they are. You know, using Hiera, what all your config values are. It just removes a lot of the effort having to describe your infrastructure, either to yourself or more likely to your team members, in particular when you're scaling your team up, hiring new operations people. hiring new people into your development team, you can just say, look at the Puppet code, and you can see exactly what the infrastructure is. And finally, you can also do interesting things around failover. So when you've got, for example, your load balancer config in Hira, you can change IPs and you can change destinations for particular paths just by making a change to the key value store, either from the command line or from the Puppet interface. And this really takes out a lot of effort having to do failover where it requires a manual action. Ideally, you can automate things, and again, you can use the different Puppet APIs to figure out what's changed and when. But there are certain procedures that you need to do during failover situations that you want a human to actually do. And you want to try and avoid as many mistakes or problems as possible. Putting a graphical interface in front of that helps. Having a script that does it is the same kind of thing from the command line. It means automating a procedure using APIs so you don't have to manually run commands where you could make a typo, miss a command, or miss a server. And allowing Puppet to make these changes probably faster than you can do across all of your infrastructure is really useful for recovering quickly and dealing with outages and doing the bare minimum you can get away with at those really inconvenient times when you don't want to be dealing with failure. And this all ties back into why Puppet. And config management is kind of the default use case, but all these different tools, the features of Puppet itself, PuppetDB, Hire, and Factor, they allow you to build your own tools, build things for your development teams, for your operations teams. They're all APIs. It's essentially an API for your infrastructure. And it's nicely abstracted so that it works across any vendor, any environment, any operating system. And that is essentially why you should be using Puppet. Thank you very much.
Thanks, David. Do folks have any questions? Anything you've been thinking, you've kind of been stewing on this morning? I know there's a lot of new folks out there today as well. Oh, come on. You can do this. Give me at least one question. Thank you.
Hello. I'd like to know an example or something about the build automation. Like normally when you have a project, you have to run some custom code or something to deploy that project. So how can we do it with Puppet?
So if you need to run custom code, then you can do that within the Puppet manifests themselves. You can use the exec command to do that, but I would ask why you're running custom code and what that actually does, and whether you can actually switch that into something that can be automated within the existing Puppet modules. So for example, if you're restarting something, you don't need to write a script for that. You can just run the restart operator as part of the Puppet run. Or if you're making schema changes, for example, then that's running a particular command against the database. And you can use the exec command to make sure that the state doesn't exist first, then run it, and then when the state changes, it doesn't run it again. So I think all of these things can be wrapped into the existing Puppet language. But in every case, I would ask, can you put it into something that is built into the Puppet language itself or one of the existing Puppet modules rather than running lots of custom scripts?
Anything else? Great. Thank you so much, David.
Thank you. Thanks.